janitor is sturdy, and he was down there a long time before as well. So.
This broadcast is designed to share Titan Tough with every Leaf Remini family across the United States and wherever we can find them. And so we're going to share with you today a bunch of information about Titan Tough. We've got a speaker, Dr. Joshua Schiffman, who runs the Schiffman Laboratory at the Huntsman Cancer Institute. And we have our board speaking, as well as some genetic counselors. So by the end of today, you'll know everything there is to know about Titan Tough and what we can do in the Leaf Remini community and to help raise some funds for the family. So this broadcast is for the family, so I hope you enjoy it. The first speaker, we're going to have Reagan's video first, and then we will hear from Amanda Gammon, who is a genetic counselor from the Huntsman Cancer Institute.
My name's Reagan Everett and I have brain cancer. Leaf-Remini syndrome ups the risk of cancer 90% in women and 73% in men. When I was in 7th grade, I had a routine MRI and they found a tumor on my left femur bone. I had surgery at Primary Children's Hospital. They removed 3 inches of my bone and put a 12-inch titanium rod in place. When I was 17 years old, I was diagnosed with a brain tumor. I had to go to Huntsman Cancer Institute and get surgery. The most terrifying part was saying goodbye to my family. When I woke up from my surgery, there was a lot of pain because I wasn't allowed to have pain medicine for 24 hours, and I had 26 staples in my head. After brain surgery, the doctors made me do a lot of things, made me move my arms, my feet, and they asked me questions. They had to wake me up every 15 minutes to make sure my brain wasn't swelling. After my brain surgery, I was having another MRI, and they found a nerve sheath tumor on my carotid artery, and I had to have it biopsied. I have to have full body MRIs every year, and every 3 months I have brain MRIs. When I was 8 years old, I had to be tested for Leaf-Remini syndrome, and I don't really remember much. All I remember is getting my blood taken and coming up the next day and everyone in my family was crying. Living with cancer is very difficult. Some days I think about it all the time. Others I've trained myself not to think about it.
Having Reagan on our softball team is an inspiration to all of us. We love watching her go out in the field and battle in softball, battle in life. Everything she does every day is an inspiration to all of us.
Having Reagan on our softball team has inspired all of us to fight and do hard things. She has shown us what it means to overcome challenges in our lives.
Reagan is just a super happy person and she's always enthusiastic, so if we're having a hard game or we're losing, she just keeps us all excited and happy and wanting to continue to try to win.
My plans for the future is to go to college and get a degree to study cancer. After my brain surgery, on the way home with my dad, I told him I didn't want anyone else to suffer from Leaf-Remini syndrome. So I decided to start a foundation called Titan Tough 21. The reason I named my foundation Titan Tough 21 is because I go to Olympus High School in Salt Lake City, Utah. Our mascot is the Titans, and I know you have to be tough to go through cancer. The number I wear in the back of my jersey is 21. And so there you go, Titan Tough 21 Foundation. The goals for Titan Tough 21 is, of course, find a cure for Leaf-Remini syndrome and provide financial assistance for all cancer patients. I'm going to work hard in the future to attain that goal. I was at Huntsman Cancer Institute at the same time as my Uncle Bryce was. He was fighting leukemia and I was fighting brain cancer. I would text my Uncle Bryce every day, encouraging quotes and telling him that he could beat cancer. The last time I saw my Uncle Bryce, I promised him I would help find a cure for Leaf-Remini syndrome. I had a hero in my family. It was my Uncle Bryce, and I loved him so much. This is my Aunt Jenny, and she's going to tell you his story.
right. Hello, I'm Amanda Gammon. I'm one of the genetic counselors at Huntsman Cancer Institute. I've worked there for about 8 years, and we see families with Li-Fraumeni syndrome and other hereditary cancer conditions. Some of the new things that we're doing at Huntsman, one thing in our clinic is we're trying to help our families that have Li-Fraumeni syndrome kind of better organize their screening and do it in a way that is hopefully can get them better insurance coverage of those screening MRIs. So what we're hoping to do are schedule maybe 3 to 4 group clinics a year, probably starting next year, so that families can come in together. They can still have separate appointments or together if they wish, and kind of see Dr. Schiffman, say, on one day, and then maybe the day or two before have their MRIs done, so then those results are available when they meet with Dr. Schiffman. But we also want to get, input from all the families that we see to know, is this a type of process that they'd like? If they could know that just, a certain time every year, say in January or in the winter, that they'd be coming in for their annual visit and their annual MRIs. Certainly there may be things that come up that, doesn't quite fall on that same schedule, but our goal is to try and get as many of those MRIs, colonoscopies, breast exams, as many of those visits all coordinated kind of within 1 or 2 days to help reduce the burden of having to come in for multiple family members all scheduled at different times kind of throughout the year. For our families that may be listening on the web, if you have a local hospital that follows patients with Li-Fraumeni syndrome, talk to them, see if they could coordinate something similar. If you're looking to find a hospital that has a screening protocol that involves full body MRI, you can bring some of the research that's available to the doctors and ask, if setting up an MRI protocol like that at your local hospital, would be available. Another thing that we're doing at Huntsman Cancer Institute in collaboration with the Utah Department of Health and Intermountain Medical Center is that we're working on a statewide genomics grant that was given to us by the CDC. Utah is one of 4 states that this year received one of these statewide genomics grants. And 2 of the measures that are being put forward by this grant is to increase education and to increase policy. What that means is to increase education among the public and among providers all throughout the state of Utah about hereditary cancer. With policy, what we're trying to do are meet with insurance companies to advocate for better coverage of not only genetic testing, but also screening MRIs, screening colonoscopies, et cetera, for individuals who need them at much younger ages and much more frequently, like our families with Li-Fraumeni syndrome. These are, a couple of the things that we have going on. A quick update on our cancer genetics study that Dr. Schiffman heads up. That's been going since 2011. We've recruited over 3,000 patients to enroll in our study, which is really crucial, providing not only family history, but DNA samples to further our research into hereditary cancer syndromes. Dr. Schiffman will be talking a little bit later about, some of the research that's come out of, using samples from patients that are enrolled in our cancer genetics study to look more into the P53 gene, its function, what it means not only for Li-Fraumeni families, but for anyone who develops cancer. So thank you very much. I just wanted to give you a few brief updates.
Okay, we're so grateful for Amanda and her expertise at the Huntsman Cancer Institute. She's worked with Reagan and several patients there, and it's just a joy to have her there, work with the patients, and get to know her. And so we appreciate you speaking. The next thing we're going to do is I want you to get a look at the Titan Tough board. So we've got 3 board members who are going to share their experience with Titan Tough and anything they'd really like to say. So these board members are going to be working hard every day, all day, 7 days a week, 365 days a year to help Titan Tough and to find a cure for Li-Fraumeni. So the first one up will be Jackson White. Then we'll have Susan Singleton and then Mike Singleton.
All right. Good morning. I'm going to just tell you a few things. I have 2 points to my speech today, and it's 1, the reason I got involved, and 2, my experience working with Titan Tough. The reason that I got involved is I am Reagan's coach and teacher, and the reason I had to look at the clock is In high school, we lunch at 10:30, so to me it's well into the afternoon, even though it's only 11:15. So apologize for not, if I say good afternoon, later on I apologize. My goal as a coach or a teacher is to instill values within my students or my players that they can learn and use for a lifetime. There's a lot of values that I try to instill on a daily basis, but the two that stick out to me the most, the two that I feel like are most important, are hard work and to never give up. These were invaluable lessons that I learned growing up playing sports, that I've continued to learn as I coach and as I teach. 4 years ago, these two lessons took on a different meaning. It was 4 years ago when Reagan was a freshman coming up to Olympus to join the softball team that I got introduced to her. And this idea of hard work and never giving up took on a different meaning than I've ever seen before. Reagan was able to introduce me to a new opponent. And every year in softball, every day in life, we face opponents. And we even are opponents ourselves. And what we try to teach is, if you're that opponent, you be a worthy opponent. You be somebody that is going to respect the rules, that is going to respect other people, and you're going to be somebody that is going to be worthy of the name opponent. You're never going to give up. You're going to continue to fight and push, and you're going to do things the right way. The opponent that Reagan introduced me to that I had never really met before in this capacity is Cancer. And Cancer, believe it or not, is a very worthy opponent. Cancer has lost millions of times. And Cancer's come back and won millions of more times. Cancer is one of those patients, or is one of those opponents that you don't want anybody to be like Cancer, but Cancer has some of those values that we try to teach each other. Cancer comes back. Cancer never quits. And when you have to go against Cancer, you have to reach those same values. You have to uphold yourself to the same values that Cancer is, which is not going to quit. So game number one, I'm going to go a little bit of a sports metaphor. Game number one, I think Reagan was a 7th grader. It's Reagan, maybe with her family members, versus a leg tumor. Leg tumor gets Reagan pretty good. Round 1, inning 1, takes her down, puts her in the hospital, removes 12 inches. What? How many? Oh, removes 3 inches of your femur, right? Femur's a huge bone. Second round, second inning, Reagan comes back, beats it. Cancer's done for game 1. Because we know Cancer is a worthy opponent, Cancer comes back a few years later when Reagan hits high school. Reagan's diagnosed with brain cancer. Game number 2. Reagan and her family versus brain cancer. Reagan's approach to this taught me so much, because instead of just getting tougher, which she did, and instead of not giving up, Reagan decided that she was going to recruit people to be on her team. She recruited the softball girls from Olympus High School. She recruited her softball coaches. She recruited some of her friends to join her team, which was her plus her family, go in game number 2. Reagan beats brain cancer. Reagan plays in every softball game that she is there, even though brain cancer was battling her probably 6 months before, maybe even less than 6 months before. So Reagan wins again. Game number 3. Reagan has, is it something with your carotid artery? Did I say it correctly? Game number 3, Reagan versus Cancer again. And there could be game number 4, and there's probably going to be game number 5, and there could be game 6, 7, 8, 9, 10, and 11. But one thing that's nice to know is that Reagan's going to stand here, and Reagan's going to fight. Reagan is going to put hard work into it, along with the rest of us. Reagan's never going to give up. But what we're doing today is we're asking everybody here, we're asking everybody that's listening to join our team. We've recruited, as Reagan's grown up, we've recruited more and more people to join our side. We've had our team grow. Our team has become stronger. Our battle versus Cancer gets a little bit harder each time, but the more people that join in on our side, Cancer doesn't stand a chance if we can get this figured out. So what we're doing this morning, whenever you see this broadcast, is we're asking you to join our team. Help in any way that you can. If it's a couple dollars here or there, great. If it's spreading the word, great. If it's taking your own kids to get them screened and tested, great. But join our team, because the stronger our team gets, the less chance cancer has, the more resilient we all become. So, just to reiterate, the reason that I joined Titan Tough, the reason that I accepted the invitation to be a board member, is because I had never been so excited in my life to become part of a team. I joined Titan Tough so that I could be a team member. My experiences with Titan Tough are very much on the community level. It was my role maybe to get Olympus High School involved a little bit. I teach here at the school. It was my role to make softball maybe play a bigger role than it has before. And we decided when Reagan was diagnosed with brain cancer, purple is the color of brain cancer, and so we decided to have a purple week for softball. We contacted one of the teams we were going to play. We asked them if they would be willing to purchase purple t-shirts, that we would purchase purple t-shirts, that we would play a purple game. We would ask for donations. We would have little things that were going on at the game. We would advertise it throughout the school. And the first year that we did Purple Week, it was a huge success. We put in, this is almost embarrassing, maybe a week's worth of preparation, and it was a lot of preparation within a week. We put in a week's worth of preparation, and we raised about $3,500, maybe a little less than $3,500. The next year, we were a little bit wiser. To carry on with my theme, our team had grown. The people that participated in Purple Week the year before wanted to do it again. There was more people that came back. So this past year when we did Purple Week, we put on things like lunchtime activities where kids could get involved. We tied ribbons. We encouraged people to pin ribbons on their shirt. One of the lunchtime activities is we sat down as a school and we wrote letters to Primary Children's Hospital, to the kids that are sitting in Primary Children's Hospital. We sold t-shirts in order to raise money for Titan Tough 21. After school, we would have events like a home run derby where we asked people to pledge $1 per home run, 50 cents per home run hit. We had a group of boys that each paid $5 to participate in this home run derby. Combined, they hit 101 home runs in about 25 or 30 minutes. We raised a couple of $1,000s from our home run derby. The week is then supposed to culminate with our purple game against, and this past year we played Woods Cross. The purple game consists of, it's a normal softball game, but in between innings, we have a little bit of fun. We let coaches hit, or we let people try to steal bases. And it was great. It brought a lot of awareness. It brought some more money in as well. And then that night, the SBOs, who were so moved by what happened, decided that they were going to throw a surprise stomp. So they bought everybody a purple or white bracelet, and I don't know how many of you can see this, but they bought everybody a purple or white bracelet. The girls got white, the boys got purple. If you wanted to ask somebody, you simply exchanged bracelets, and then you came to the stomp later that night, and all of the money raised from that stomp was donated to Titan Tough as well. Plus, we did classroom donations. We put everybody's second period against each other to see who could raise the most. I think the winning class, and it was just one class, the winning class alone donated, I think, over $800, and it was a sophomore class. It was a group of 16-year-old students that there was 39 of them in the class, donated a total of $800. At the end of the week and at the end of the donations, we had parents calling from within the community saying, hey, they've heard about what's going on, they want to help. We've had a few other businesses that wanted to get involved and donate. And although Purple Week's only been going for 2 years, this coming year will be the third year, our second year we were able to raise over $10,000 for the cause. I'm not saying that everybody out there has to go out and throw a Purple Week. I'm not saying everybody has access to a school or a community. But sometimes all it takes is just a little idea, a little spark to get everybody else involved, something fun that draws positive attention to it, because people need something to rally around sometimes. This foundation started by Reagan, this 18-year-old girl. This is a great person to rally around. So as you're sitting out there watching, as you're thinking what you can do, anything that you're willing to do, any idea that you have that you try to put in play or come forward with, no matter the monetary excess or not, will be a big help to us. It will boost our spirits. It will boost our team. It'll help us become the most worthy opponent that cancer's ever seen. Thank you.
I'm Susan Singleton. I'm extremely nervous to be here and speak, but I'm honored at the same time. I'm on the board of Titan Tough, and we too first met Reagan and James about 4 years ago because our daughter played softball with her. And at the time, and it wasn't till a little bit into our relationship that we understood that Reagan had cancer and the nature of her cancer, and they're very quiet about it. And I was taken back as I began to learn more about this Li-Fraumeni syndrome. Coincidentally, right about the same time, I had lost my best friend to a brain tumor. And so somewhere inside, my heart said, well, I need to do something for my friend, for Reagan. It just felt, life is about timing, and it just felt like, okay, I got to get on board with doing whatever we can. I'm going to talk to you a little bit more from the perspective as a parent and a mom, because it's what I know. I had no idea about the statistics, and especially not until last night. 1 in 2 men and 1 in 3 women. I had no idea. I know growing up, cancer doesn't discriminate, but I'm going to say that's not true anymore. This particular Li-Fraumeni syndrome does discriminate. These are people born with a death sentence. Some is environmental, some, I don't know enough to give an educated answer, but it does seem that this is different. The deck is stacked against them from the get-go. If we don't know someone, sooner or later we will, affected by cancer. You can't read the obituaries without seeing that is the majority of people taken by that disease. As a mom, I think about some of the other institutions I've seen that mothers have taken on in a small way to begin, and then it's grown. Mothers Against Drunk Driving. Moms Demand Action. That's a gun control. I'm not getting political here. I am saying the power of parents is incredible. I would ask that you educate yourself about this. Parents are chatty. We like to chat. Moms like to talk. Educate yourself. Know about it. Pass it on. You never know who you're talking to. You don't know who they know. We know it's a foregone conclusion that you can't throw a stone without someone having cancer. So your likelihood is good in this conversation to spark someone who said, I had no idea, much like I'm saying to you. I had no idea about this syndrome. I had no idea that if funding for it could affect and help so many other cancers. Talk about it, educate yourself. Moms talk everywhere, from your pedicure to a sports game to anywhere you can. The power of moms, the power of parents, because they're passionate about their children. They're passionate about, there's nothing more near and dear to the heartstrings. I feel really blessed to have had Reagan and James come into our lives. I feel really honored to be part of this. We are just a small organization starting, but this is a worldwide problem, and I apologize, I've tried to find the quote, but there is something to the effect of, we can all do small things, and we all should, and we all can. And the power that is between a lot of people doing a little is incredible. And so we're going to start in our own way. We would ask you to spread the word, as I said, and it's amazing, I think, what can be done. I appreciate being part of this. Thanks.
Hello, my name is Mike Singleton. I am also on the board for Titan Tough 21, and I'm proud to be on this board along with Jackson, Coach White, and my wife, and I'm really pleased to be surrounded by so many wonderful, inspiring people. I too am involved on multiple levels. First and foremost, as a friend to the family, to James and Reagan. That would be first and foremost my role. My daughter, one of my 3 daughters, her name is Ashley, met Reagan when Reagan was in 9th grade playing softball. She immediately took a liking to her, which meant that I had the option to immediately take a liking to James or not, but I did. And what I discovered was that James is one of the most caring, giving, loving fathers that I've ever met. And I am proud to be in the same company as him. So having 3 daughters, one the same age as Reagan's, she's healthy, she's cheerful, she's smart. She does not have this Lee-Fermini cancer. Reagan is all that and so much more with regard to her challenge, this determination that she has. I think Reagan is perhaps the most energetic, enthusiastic, fun, loving, kind person that I've ever met. She never stops. She's always smiling. You would never know that she has this disease. She doesn't whine. She gets up. She does what she wants to do, needs to do, loves to do, and she wants to live. And we all want to live. That's really the bottom line, is that she wants to live. And her deck of cards right now is stacked against her. So we need help. Titan Tough 21 needs help. So that's who I am. Why I'm here is for James and Reagan and Reagan's parents, her mom Rebecca and her brother and their family members who have also passed on through this disease, and for family members who are still living and have lost those family members. Tragic, and it doesn't have to happen, and it shouldn't have to happen. But it will continue to happen unless we get involved. And we, being anyone who listens to this broadcast, anyone who's listening now, anyone who's going to listen in the future, us people here, it's only going to be us who makes the difference. We have to help make the difference. Okay, about me personally, I've owned a business for 25 years. So now here comes the real me, all right? I'm a salesman. That's what I do. I've owned an art publishing company for 25 years. So what I learned in order to be successful in life, in business, is that you need other people. Not one person can win the softball game. Not one person can run a company and be as successful as you want to. So what I learned is that you have to ask for what you want. We need $5 million. Okay? That's what we need. We need $5 million to give to the Cancer Institute, to go specifically for Lee-Fermini disease, to Dr. Schiffman and his wonderful staff, so that we can take an enormous bite out of this disease. So we're asking for $5 million. How are we going to get that? How are we going to get that? Well, here's my thought. For whomever watches this, we need 5 million people to give $1. It's really that simple. So we need 5 million people to give $1. And that should be the goal. And if we get more, wonderful. But there isn't anyone on the planet that can't come up with $1. So let's figure out a way to get $1 for Lee-Fermini disease from 5 million people, and to save others, and to also save those who don't have Li-Fraumeni cancer, but other cancers. And that's what I'm going to be involved in. The majority of my time now spent to that. And if we get 10 million, twice as good, 20, 30. We won't just spend it on Li-Fraumeni. We'll save lives. We'll be saving lives. And there's nothing more important than that. So let me end with the story that we all know about, David and Goliath. Right now, Goliath is huge. David seems small. Li-Fraumeni, cancer. But we all know what happened in the end. Goliath went down. Cancer will too go down. It can go down quicker. It can go down faster if we can get the money and the support and rally around and really knock this thing out. Again, happy to be a part of this. Thank you.
Welcome to the Schiffman Lab. Come on in. Let's take a look. Welcome to the Schiffman Lab. This is where we do our experiments and research to try to understand who gets cancer and why. We'll take a quick tour and we'll introduce you to some of the machines and people that we have in the lab to help answer these questions. This is Trent Fowler, our lab manager. Trent, why don't you tell the folks at home a little bit about what it is we do here and some of the equipment that we have.
Our job here in the Schiffman Lab is to actually look at the differences between cells. So Dr. Schiffman talked about earlier how elephants don't get as much cancer as dogs and humans, and dogs get more cancer than humans. So our job in the lab here is to look at the actual differences between each cell and figure out why they don't get cancer. So this machine right here is actually a quantitative PCR machine that allows us to look at expression levels of different genes. We use a lot of centrifuges and things like that to spin down and process the blood to look at cancer.
In the lab, we're always searching, constantly on the lookout to try to understand what is the risk for cancer. How does this mutation in P53 cause cancer in Li-Fraumeni syndrome? Some of the really exciting discoveries that we're onto is animals that don't get cancer and what is their genetic risk, and how do we learn why they're protected from cancer and apply that to patients with Li-Fraumeni syndrome. We're also looking at new genomic technology where you could take just a drop of blood from a patient and try to learn and see, do they already have cancer? Can we intervene early on before it's too late? We're also now trying to explore ways of actually taking P53 and giving it back to the patient. Is there a way using new genomics and nanotechnology and all of the brightest minds that we've gathered and assembled here in the lab to try to figure out through these collaborations, not just in Utah, but around the world working together, how do we help these patients? How do we use what we've learned from the biology of P53 right here in our laboratory and give that back to the patients? The elephants that we're studying, their blood comes in straight from the zoo, fresh elephant blood hand-delivered right to this lab station where we're able to actually take the blood and separate it out, manipulate it, measure the different expression levels, and do the experiments so that we can try to understand why elephants don't get cancer and what we can do about that to try to learn for our patients. The whole goal of everything we do and everything you see around here is try to understand the origins of cancer and most importantly, take that genomic information and translate it back to the patients. So we always start with the patient samples, or patients like Reagan, where there's a clinical problem. So for instance, with Li-Fraumeni syndrome, these patients are getting much more cancer than we would expect by chance alone. Take it to the lab, explore the biological samples, come up with hypotheses, test those hypotheses in the laboratory setting, and then figure out a way to bring that full circle back to the patient. Here's Reagan's blood that we just drew, and now Lisa is separating it out so that we can try to understand what's Reagan's risk for cancer, and how can we learn from that to help prevent cancer in Reagan and all the other patients with Li-Fraumeni syndrome. So here we have chromosomes, or the DNA, of different patients. This one is from a person who doesn't have Li-Fraumeni syndrome, and these chromosomes are from a patient that does have Li-Fraumeni syndrome. What we were able to show was that those patients with Li-Fraumeni syndrome have many more changes or abnormalities in their DNA. This is a patient who doesn't have Li-Fraumeni syndrome, and we took the cells and exposed them to radiation, and there were a couple of changes, as you would expect. But when you take the Li-Fraumeni patient cells and you expose them to radiation, there's a tremendous amount of mutations, changes, alterations that go on, and this is one of the reasons we think these patients go on to develop cancer throughout their lifetime. This is our tissue culture, where we actually take live cells from patients and even elephants and grow them under the hood. Here we can actually see how the cells develop, change, respond to different types of treatments. Many of these cells are actually stored here in our incubator. What you see here are rows and rows of cells, and inside these cells are actually growing and expanding and responding differently to the various treatments that we've given them. Here we see Lisa, our research associate in the Schiffman lab, preparing for the next round of experiments with the blood that we've just drawn from Reagan. She'll take this blood and compare it to a person who doesn't have Li-Fraumeni syndrome, as well as to an elephant which rarely gets cancer. By doing this, we can understand the differences between each of these different genetic backgrounds, and again, use that information to help in the treatment, care, and management of patients with and without Li-Fraumeni syndrome.
I think there's a lot of really, really good hope for patients with Li-Fraumeni syndrome, in that the research is progressing so well. We're finding a lot of things that can really make a huge impact in Li-Fraumeni research that we didn't know even 5 years ago. I have the opportunity to meet some of the patients in the clinic and collect their blood. It's so meaningful for me because it feels like, in many senses, these individuals, especially these kids, were really robbed of a chance to live a full and problem-free life. And if I can do anything to help to alleviate their suffering in any way, I think it's definitely worth my time.
One of the amazing things about working in a place like the University of Utah is the seamless connection between Primary Children's Hospital, where we provide clinical care for these patients, and the research that's done right here in the lab at Huntsman Cancer Institute. We flow back and forth between these two great institutions where we're able to cure cancer in children and their families, and then research their blood and their genetics to try to figure out how do we actually make a difference and impact for some of those children who weren't quite as lucky to be cured this time around. It's really this connection, this collaboration, this teamwork that makes us strong and makes us tight and tough, and is going to really make an impact to cure cancer, to understand Li-Fraumeni syndrome, and to make a difference in the lives of children and families across the world.
Well, I appreciate our board members speaking. They're great individuals, as you can see, and they volunteer their time to help Dr. Schiffman and help Reagan and help the Thompson families find a cure for Li-Fraumeni, as well as all the families listening to this web broadcast tonight, or this morning. We're so grateful for people and volunteers that will come forward and use their time. A great story that I would like to tell is Jackson White just had a baby girl, and he is so proud of her. We were here last night, and we were doing a launch meeting with some special people, and after we ate and after we spoke, Jackson came up, and I could see him right in his face. He was anxious to get to that baby girl. Yeah, I could just see it. I got to get myself home. And he said, James, can I go home? I said, sure, you can go home. And so he now feels, and he's a brand new father, how all the Lee Fermini families feel, and all the parents with kids with cancer, how you want to get to them. You want to make sure they're helping. You want to make sure they're happy. And so I'd love to see that in Jackson. You can see his enthusiasm. He's a team player, and he's ready to rock and roll with Titan Tough 21. So I'm so grateful for the volunteers, and I'm grateful for the Lee Fermini families watching this broadcast. And I'm going to share in a few minutes after Dr. Schiffman how we can reach that $5 million goal. Before that, we'll hear from Dr. Joshua Schiffman, some background on him. Of course, he is the director of the Schiffman Laboratory at the Huntsman Cancer Institute. He's got so many degrees and honorships, professorships that I can't go through them all. I often joke with Josh, you need to have 2 business cards, not just one, with all of your titles. And he just looks at me and smiles. One of the most humble individuals I've ever met. And I've known him for almost a decade, and I love him. He is such a great individual. And he's going to share right now a little bit of his information on the, in his Lee Fermini lab. One last thing, if you can't go to Google without seeing Josh, he's in Time Magazine. He's in Newsweek Magazine. He's been on CNBC. He's been on NBC. He works with Ringling Brothers and Barnum and Bailey Circus. In my opinion, he is the man in Lee Fermini. There are other great researchers out there, but I have a special place in my heart, so I'll introduce Joshua Schiffman.
Thanks. Give you a hug.
You bet.
All right. So the first thing that I need to tell everyone, and especially the web viewers, is this is really a team effort, right? Just like any sports team, I'm just one person on a team full of many great people, including the Lee Fermini families, which are perhaps the most important of all the team members. All right, so over the next, over the next half hour or so, I'm going to tell you a little bit of a story about our research and what we've done together and where we're hoping to go with your help and maybe those who are watching this web broadcast. So let's see, is this advance? Looks like, oh, there we go. Okay, so, yeah, thanks. So the first thing is just to recognize how important it is to try to understand cancer. Cancer is everywhere. It's the second leading cause of death worldwide. 8 million deaths per year. And in fact, 15 people will die from cancer every minute around the world. That means in an hour, 2 hours, thousands of lives will be lost to cancer. Why does it matter? Well, half of all women, half of all men and a third of all women throughout their lifetime will develop cancer. Right? That means if you're at home right now and there's someone else in the room with you, either you or that other person is going to get cancer. And as we're going to talk about, P53, which is a gene that we all have, is one of the most important genes in cancer. And in fact, in over half of all human cancers, this is a gene that is involved, whether or not you have Lee Fermini syndrome. So cancer and P53, very, very important. And in terms of children, cancer is the leading cause of disease-related death. One child with cancer is one child too many. And we need to work hard to understand what we can do about it. Now, in terms of the genetic risk for cancer, in adults, what we think is about 1 in 10 of cancers are due to an underlying genetic risk, so something that's inherent to the patient, something they're born with. But in children, that comes to 1 in 3, right? Cancer is a disease of aging. As we get older, our bodies don't work as well as they used to, as I'm learning, as I'm getting older. And in fact, one of the things that stops working so well turns out to be our P53 genes. And as we age, our ability to fix damage to our DNA is not as good as it used to be. So if you're an adult and you live long enough, there's a pretty good chance that you'll get cancer. But what about kids, right? We have children, we know children. These kids shouldn't be getting cancer. What's going on there? And we think that as many as 1 in 3 cancers in children may be due to an underlying genetic risk. Not all from Li-Fraumeni syndrome, but there may be something in their DNA that is making them more susceptible to develop cancer, because cancer shouldn't be happening in children. And it turns out that this translates into almost 4,500 kids, right? Nearly 5,000 children a year in North America who may have a genetic risk for cancer. And when you think about the entire population and all of the genetic risk for cancer, it turns out that walking around our streets, there are nearly 1.7 million people who are at genetic risk for cancer. Why am I telling you all of this? Because I want to get the point across. Cancer matters. And it matters to an awful lot of people. Let's talk a little bit about Li-Fraumeni syndrome, right? That's why we're here today. That's why Reagan has done such a wonderful job of pulling us all together in this room and those at home or in their office watching this video. What is Li-Fraumeni syndrome? Well, Li-Fraumeni syndrome is a condition whereby there is an increased risk lifelong of developing cancer. Thank you. And it could be any type of cancer. It could be brain cancer, bone cancer, lung cancer, breast cancer, anywhere throughout your body. And your lifetime risk, if you have Li-Fraumeni syndrome, may be as high as, in some cases, 100%. Now, imagine being a patient, being a kid. Imagine being Reagan, sitting right here in the front, and being told by a doctor like me, Reagan, you have 100% chance that you're going to get cancer throughout your lifetime. She already knows that. She's already had several cancers. What's that like for a parent, knowing that you have a child that has 100% lifetime risk, or a spouse who has 100% lifetime risk? We need to do something about this desperately, and that's why we're all here today, and that's why I'm pleased to talk to you about some of the research that we're doing together in our lab with collaborators to try to understand how can we hopefully one day make a difference. Now, the thing about Li-Fraumeni syndrome is it's due to a very specific mutation in a gene that we've already talked about called P53. And what is a gene? And I see we have some younger folks in the audience today, which is great. And when we talk about genes, we're not talking about the type of jeans that you wear, right? We're not talking about your Levi jeans, or those of you who are older, remember your Jordache jeans, right? These are different types. See, she's smiling. She knows she has a pair at home in the closet. We're talking about DNA, right? We all inherit DNA from our parents. And that DNA makes genes. And genes are like the blueprints or the instruction manuals for our body. And each gene has a different job. And we have 2 copies of every gene in our body. We get 1 copy from our mom and 1 copy from our dad. So we're all supposed to have 2 copies. Now there's one gene, a very special gene, called P53. This is what it looks like, a whole bunch of squiggles. But when I think about P53, and I talk to families about P53, I think of a gene in its underpants with a cape flying behind its back, the superhero of our genome. This is Captain P53. We even call it the guardian of the genome. That's what the doctors and scientists call it. Why? Because this guy, P53, who just disappeared on the screen, and now going backwards, is so important. Okay, there he is again. We need P53 to make sure we don't get cancer. And P53 has 2 very important jobs. It has many important jobs, but two of them that we're going to talk about today are how it helps to prevent cancer. We all have cells in our body, right? And those cells are dividing and growing all the time, and those cells will develop mutations or alterations in their DNA. When that happens, P53 flies onto the scene, makes sure that our cells are okay, stops our cells, helps to stop them from dividing, so that we can fix those changes and that those changes in the DNA don't go on to become leukemia or breast cancer or brain tumors, right? It helps to prevent that cell from turning into cancer. And if P53 and his other P53 buddies can't stop that cell from dividing and fixing it, then they just go on and they kill it. They say, all right, cell, we gave it our best shot, and cell suicide, right? They make the cell die. So it's a pretty good system. Patients with Li-Fraumeni syndrome only have one P53 gene instead of two. And if you only have one, it's a lot harder to prevent that cell from going on and becoming cancer. And that's why there's such a high risk of cancer when you have Li-Fraumeni syndrome. Now here is an example of a family with Li-Fraumeni syndrome, and every red line, or every red circle here, is someone in this family who has had a brain tumor. Many of them have died of brain tumors, and there are other family members as well who've had adrenal tumors, lung tumors, sarcomas, leukemias. And this, as it turns out, and I've had permission to show this, is Reagan's family. Now, when we first met Reagan, and she was only 12 years old, we looked and we screened her, and what we found was that she actually had a brain tumor. And we continued to screen her year after year because the brain tumor was too small to do anything about, and then, as you've heard, she developed another brain tumor. She didn't have any symptoms, but we knew she was at high genetic risk. And then her cousin, we also screened, and he had a brain tumor. And this brain tumor has come back, and we've done surgery, but we know to look. So if you have a genetic risk, we know to be on the lookout for it. And this is a picture of Reagan's cousin Tony, and we were able, again, I have permission to show this photo, we were able to help save his life because we knew he had a high risk for cancer, and we found it early. And one of the most rewarding things about being a doctor taking care of patients with Li-Fraumeni syndrome and finding cancer early is, you know, we didn't just save Tony's life, if you think about it. We saved the lives of all of his children, some of who weren't even born yet when we first found his tumor. And I've made Reagan promise me that when the time comes, she's going to give me a slide with all of her kids and all of the lives that we saved for her children, yet to be born. But that's another lecture for another day. Okay? Now, one of the things that we found working very closely with Li-Fraumeni researchers and doctors from around the country, because it's all collaborative, right? You can't do this on your own. And this was a study led by Dr. David Malkin at Toronto Sick Kids that we participated in, along with Dr. Jonathan Finley, who was at Children's Hospital of Los Angeles at the time. And what we found was when we looked for cancer in patients before they even had symptoms, we were able to actually save an incredible amount of lives. We looked and looked and looked, and those patients who participated in this screening study, when we found the cancer early, because we were looking for it, they had 100% survival, which is that top line. And unfortunately, those patients who didn't participate in the screening and presented with their symptoms after they already had their tumor, unfortunately, only 20% survived. So 100% survival versus 20% survival. Now, this is only 3 years, and unfortunately, some of the patients who we did find tumors early did eventually go on to die, but we know the earlier you find a tumor, the better the outcome. And this is in contrast with some of the studies out there for other medicines. This is a drug called Avastin. This is a very common drug used now. It's a very expensive drug, hundreds of thousands of dollars, and this is considered a success in the world of oncology, right? This is a blockbuster drug. And what I want to show you is Each of these lines, this is how many patients survive. And if you look on the bottom line, these are the patients who got the regular standard therapy, and of course many of them went on to die. And if you added on this blockbuster drug, this amazing, wonderful drug, that's the purple line. And if you look, they all still died. Now, if you read the fine print, it was 12.3 months versus 10.3 months if you use this new, amazing, super expensive drug. So you got 2 months, but everyone still died. And this is currently what's considered a success in oncology. Here's another example, right? So this drug, you get 6.7 months versus 4.7 months, but look, everyone still dies, and this is very, very common in the world of oncology. So we need a better drug, and I'm going to tell you in a few minutes about some of our hopes about maybe how we can do better than this. The other thing to point out is this gentleman was so confident in these results, he got a tattoo on his arm. 6.7 months, to try to impress his lady friend, I'm assuming. But the truth is, that's not the right number, right? That 6.7, that should really say 2 months, because you only get 2 months. Everyone got 4.7 months. It was only when you added the drug, you got an extra 2 months. So that should say 2 months, but again, probably wouldn't have impressed his friends, so he had to go with 6.7 months. But this is not good enough. This is why we and others are working so hard around the clock to try to get curves that look more like that. And here are some of the tumors that we found in our patients that we take care of at Primary Children's Hospital and Huntsman Cancer Institute here in Salt Lake City, the University of Utah. And we're finding tumors early, before these patients already even knew they had cancer. Here's a young man who had osteosarcoma when he was 19, and 3 years later on his whole body MRI scan, we were able to find a colorectal cancer. He didn't even know he had it. So we feel like identifying who's at genetic risk can really be helpful in saving lives. And here is where we work in Salt Lake City. Again, a collaboration, a seamless collaboration between the Children's Hospital and right across the street, Huntsman Cancer Institute. Here's where we take care of the patients and try to pioneer cancer prevention for the community. Here's where we do the basic science laboratory research. And going back and forth, we feel this is what has allowed us to be so successful working with patients, working with families, also working in a top-class cancer research laboratory. And this, we hope, is why we're going to continue to be successful. We enroll all of our patients, whether they have Li-Fraumeni syndrome or not. We look at their DNA, we look at their genetics, and we try to understand where does cancer come from and what can we do about it. And in fact, one of the things we've been thinking about recently, every time a child is born anywhere in the US, right, they get a heel stick. We look, here's a little guy, he's about a couple hours old. We check his blood to make sure he doesn't have something called PKU and other metabolic syndromes, very, very rare, 1 in 10,000, 1 in 15,000. But if we find that 1 in 15,000 patient, guess what? We can intervene and help to make sure that kiddo lives a long and healthy life. Well, childhood cancer occurs 1 in 300. We don't have a gene that we know of that causes all childhood cancer, so we can't yet screen for the cancer gene. But guess what? We do have a gene for Li-Fraumeni syndrome. That's P53, right? That's the gene that Reagan has that's mutated in other members of her family and other people around the world with Li-Fraumeni syndrome. That occurs in 1 in 5,000, maybe even closer to 1 in 2,500. Much more common than PKU. And we were just talking about if we know someone has Li-Fraumeni syndrome, we can start screening early on so that we can intervene. And one of the things we're looking at in our lab and with our collaborators is there a way that we could start screening all newborns around the world to see if they carry the P53 gene? Now, it's a lot easier to say it than to do it because we have to figure out how would we do genetic counseling, how would we make sure that the result is real, How do we do it without causing anxiety to the families? And will it actually make a difference? We believe it will, but these are some of the things that we are trying to understand now because we do want to save lives. Now, I'm going to just spend a couple minutes talking about elephants and cancer and Li-Fraumeni syndrome. And some of you may be wondering, what in the heck does an elephant have to do with Li-Fraumeni syndrome? And I'm going to tell you right now. 3 years ago, I was at a conference in Maine. Has anyone been to Bar Harbor, Maine? Yes, in the back, James has. Great lobster. I recommend everyone go and just try the lobster. Okay? But they also have a fantastic biological laboratory there, and we were talking about evolution in cancer. And it was at this meeting that I first met Dr. Carlo Meli. Dr. Meli was running the Center for Evolution in Cancer at UC San Francisco. He's now working at Arizona State University. And I didn't know him beforehand, but he was talking about this idea of something called Peto's paradox, which I had never heard of before. Sir Richard Peto was a statistician interested in epidemiology who made the observation that if you think about it, animals with a lot of cells, right, like elephants, 100 times the size of people, or whales. Did you know a whale is 1,000 times the size of a person? She said no. She nodded no. I could see it in your eyes. You didn't know that. But that means that elephants have 100 times as many cells as people. Whales have 1,000 times as many cells as people. Elephants live 60, 70 years. That many cells dividing all the time, day after day after day. In such a large animal like an elephant, for so long, just by chance alone, you would expect almost all elephants to develop cancer. But they don't. Elephants, Dr. Meli explained, had some of the lowest cancer rates on the planet. And that was known as the paradox. Why is it that such a big animal living for so long almost never gets cancer? And it probably makes sense from an evolutionary point of view, because if they did get cancer and they got a lot of it, they'd probably go extinct. And extinction is not really a good strategy for survival. So Dr. Meli explained that there probably was some reason why elephants evolved to be protected from cancer, as opposed to little mice that tend to be cancer prone, and which is why we use them so much in the laboratory to help us understand the risk for cancer. But these big guys, which at the time we didn't have in the laboratory, right, just never seemed to get cancer. And a light bulb went off in my head. And I said, you know, we spend so much time taking care of patients with Li-Fraumeni syndrome, trying to understand why does cancer happen and who gets more cancer. What if we flipped it all around and instead started trying to understand who doesn't get cancer, like the elephant, and can we learn from that and maybe come up with a way to help our patients? Now, Dr. Meli also explained when they looked at the genome of the African elephants, what they found in the DNA, that instead of 2 copies of P53, like you and I have, elephants had evolved 40 copies of P53. And Dr. Meli explained that he thought this could possibly be the reason why elephants didn't get cancer, but how could you know for sure? After the talk, I introduced myself to Dr. Meli, and I explained that we have a lab at the University of Utah where we take care of patients with Li-Fraumeni syndrome, like Reagan, and study their blood and how their DNA responds to DNA damage. And what if, Dr. Meli, I asked, we could get some elephant blood and study that elephant blood right next to the Li-Fraumeni blood and try to understand how elephants are preventing cancer? And he thought that was a great idea, and he said, Josh, where are you going to get elephant blood from? And I said, I have absolutely no idea. And he said, well, neither do I. So I went home and I forgot about the whole thing, and you know, here's this concept of Peto's paradox. They have 100 times as many cells, why don't they get cancer? But it really kind of was in the back of my mind. I moved on to other things. Until my wife told me, you know what, you should take the kids and you should go to the zoo. You should spend more time with our kids. You're always working in the lab. Have a day off. So I tried the best I could. took the kids to the zoo, and I said, kids, let's go look at the elephants at the zoo. Right? I didn't really take the day off. Don't tell my wife, because I was still thinking a little bit about these elephants. And at the zoo, we saw an elephant show at Utah's Hogle Zoo, where Eric Peterson, who's the elephant manager, explained that at the zoo, they actually draw blood from their elephants to make sure that their elephants stay healthy and that their hormones are in balance and so forth. And then, everyone clapped and the show was over, and he said, if you have any questions, you can come up front. So I did the only thing I could do, right, Reagan? You've heard this story before. I went up to Mr. Eric Peterson and I asked my question. And my question was, Eric, how can we get some of this elephant blood to study in our lab? Now, luckily, Eric didn't call security, right, which he could have, some crazy guy asking for elephant blood. And we worked with Utah's Hogle Zoo, and we filled out the right paperwork and went through the right review process. And since that time, once a week, our study coordinators, instead of getting blood from our patients with Li-Fraumeni syndrome, they go down to the zoo, they get the blood while it's being drawn, and again, they're drawing it anyways to just make sure the elephants are healthy. They just draw a little bit extra, and they rush it back to our lab, and Dr. Beglin and others in our lab have studied it to try to understand why elephants don't get cancer. Now, one of the things that we found that was quite surprising, and you might not be able to see this so well, is that when we looked, and this is a study that just came out last week in JAMA, when we looked to try to understand were the elephant cells repairing their DNA damage any quicker than the patients or just humans, regular humans, they weren't. In fact, they were repairing about the same time. And again, it doesn't really project very well here, but we thought when we take the cells, right? So Lisa and others in our lab, they take those elephant cells. They take the blood, they spin the blood down really quickly, they take out the cells, they put the cells in a dish. They do the same thing with human cells, and then she zaps it with radiation to cause DNA damage, to break those DNA up and cause mutations. And then we look and we see, are they fixing it any faster? And it turns out they were fixing it about the same rate. But what Lisa and others found was that they were actually dying more quickly. So the elephant cells were all dying off at almost twice the rate of the human cells. And the elephant cells were dying off at almost 5 times the rate of the Li-Fraumeni cells. And here's one of the pictures from the paper that we just published together with, again, many different collaborators. And what we saw is, here's patients with Li-Fraumeni syndrome, all right? These are folks who have only one working copy of that P53 gene, all right? This is very, very exciting, so stay with me for this figure. Lisa takes the cells from patients with Li-Fraumeni syndrome. She zaps them with radiation. They get all sorts of DNA damage. And we look and we see how many of those cells are dying off, right? And they should hopefully be dying off because they have all mutations. But with Li-Fraumeni syndrome, only a small percentage were actually dying off. Then we looked at patients with 2 copies of P53, our human controls, and about twice as many were dying off, right? More than the patients with Li-Fraumeni syndrome. And we think this is why patients, again, with Li-Fraumeni get so much cancer, because they don't have that working P53. They only have 1 copy. So they can't stop those cells, and those cells eventually in the patient would go on to cause cancer. With humans, well, about twice as many were dying. We didn't get all of them, but we got some of them. And then look at the elephants, way up high, 40 copies of P53. And so the only thing you really need to know about this picture up here is, here's a patient with almost 100% lifetime risk of cancer, and only 1 P53 gene, and just a little bit of those cells dying when they had DNA damage. Here's a healthy patient with twice as many P53, twice as many cells dying, and about 50% lifetime risk of cancer. So that extra copy of P53 seems to be protecting them. And then here are the elephants with 40 copies and a whole bunch of apoptosis, more than 5 times as much as the Li-Fraumeni patients, and less than 5% cancer rate in the elephant. All right? Now, just the take-home point of all of this is that elephants rarely get cancer. Elephants have a lot of P53, and we're working to try to understand how many of those extra copies of P53 are actually working and functioning, because they're probably not all working, and they might be working a little bit different than the human p53, but we think, because of the work that Lisa and others have done, that it's contributing to this increased rate of cell death. You guys with me so far? Everyone out there in webland with me? Okay, good. Just nod your head. We can see you through the screen. We're watching. Okay, good. So what we think is that the answer to Peto's paradox, the way the elephant has figured out how not to get cancer, is potentially through these extra copies of p53 and basically killing off any damaged cell. And so this is very exciting because this means that in the course of 55 million years of evolution, right, we went back and looked at the hyrax, which is a small little mammal that's related to the elephant, and we looked at the DNA in the hyrax, and they didn't have these 40 copies of p53, these extra retrogene copies. So we think somewhere in the course of an elephant becoming an elephant over 55 million years is when these extra copies of p53 got inserted. And now we want to look at all different animals and see, are they protected from cancer? How do they repair their DNA? Is it related to p53 or something different? We think it might be something different. And we also wanted to look at different types of elephants, particularly the Asian elephant. Utah's Hogle Zoo has African elephants. And it turns out that we were able to partner and have an amazing relationship with, you guys may be familiar with this, Ringling Brothers in Barnum and Bailey Circus, right? The greatest show on earth. Now we're wondering, can these elephants from the circus lead to maybe one day the greatest cure on earth? And working with Ringling Brothers, who has the largest herd of Asian elephants in North America, and they have a Center for Elephant Conservation, now we have access to a tremendous amount of samples from these elephants to study and try to understand. And in fact, Ringling Brothers has committed funding and partnership with us and Primary Children's Hospital and our Pediatric Cancer Research Program to try to pursue this as much as we can, working together. Now, the last part of the talk, I just want to mention one thing where we're going in the future, okay? With the elephants, one of the things we want to try to do and use any type of funding and support that we can gather, right? Like we talked about, if everyone gives $1, that would be tremendous. We want to be able to see, can we get that elephant p53, right? Can we get all these elephants have extra copies of p53. Can we use new technology, new genomic strategies to try to actually deliver elephant p53 to the patient, to their cells that are most at risk for developing cancer? Maybe they have pre-cancer, maybe they already have cancer, maybe they have genomic instability, so changes in their DNA. Can we get that elephant p53 to do its job in a person? And Dr. Beglin and others in our lab have shown that we can take elephant p53 genes and put them in human cells in a dish, but we want to see, can we do it in an actual patient? And so that's what we're working so hard to find. And then also, can we maybe find a drug that mimics the effect of those extra copies of p53 and kills the cell just like the elephants are doing, right? This stuff blows my mind. It sounds like science fiction, except it's real. And we are working so hard to try to understand what can we do about it. Now, the last part, like I mentioned, the other thing that we're working on in our lab is a study across all of North America. And this is going to be done hopefully in conjunction with Dr. Malkin's group in Toronto as well, who's one of the leaders in the field of Li-Fraumeni research. In fact, Dr. Malkin was the person who first figured out that it was the p53 gene that was involved in Li-Fraumeni syndrome. So what we're trying to do is see if we can identify tumors earlier than we are doing already with the whole body MRI. And can we use this circulating tumor DNA? Every time a tumor grows in a person, it has those mutations in DNA like we talked about. And those mutations break off and go into the bloodstream and circulate around. Well, now there are tests where you can get a couple drops of blood and you could look in the blood in the plasma from the patient and see, are there any mutations that means there may be a tumor in that patient? And we're wondering, if we do that, can we find that tumor before it's causing any symptoms, before it might even be able to be seen on MRI? And this would be incredible. And many different tumors, many of the same types of tumors that patients with Li-Fraumeni develop, shed this circulating tumor DNA. And in fact, there are several companies now that actually are trying to offer this test. But what I caution, and this is also important for everyone in the room and anyone who might be watching, is we need to do a clinical trial to actually learn if it works. Just because the test is available doesn't mean the test is the right thing to do. We think it is, but we need to do the study to demonstrate it. We need to understand, how sensitive is this test? How good a job does it do picking up tumors? And how specific is it? If it does pick it up, is it really picking up a true tumor? Or is it perhaps something else? And what type of tumor could it be? So here's our plan, right? And this is also why, if everyone just gives $1, this would be a phenomenal study, right? I feel a little bit like I'm doing a ShamWow commercial up here, but this is what we're trying to do, right? This is how we're trying to help Reagan and all of our families that we care for with Li-Fraumeni syndrome. We want to get every patient with Li-Fraumeni across North America, whether they are an adult or a child, to agree to participate in this study. We'll mail them consent. We will consent them and make sure that they understand what the study is. And we will collect their blood, and we will measure to see if there's any circulating tumor DNA. Now, what happens if we find it? That doesn't mean they have a tumor. This is what the study is for, to try to understand, is this a test that can work? But if we find any clues, any indication that, you know what, there is increased tumor DNA floating in their blood, then what we want to do is we want to invite all of the patients who are positive for that, meaning that we find that mutation, to come to Salt Lake City, right, to Primary Children's Hospital or Huntsman Cancer Institute, to do a whole body MRI, to do further testing. Maybe we'll be able to work with their local institution, but again, we want the study to pay for all of this, to try to do follow-up testing to see how sensitive, how specific is this test. Is circulating tumor DNA the next thing in terms of identifying early tumors? Because we know the earlier you find a tumor in a patient, the better they do. And maybe one day in the future, if we're lucky enough and we work hard enough, if we find tumors early in patients, maybe using this, maybe using something new, then we can use what we learned from the elephants as a way of treating those patients, right? So hopefully you see how this is all coming together. So I want to be very clear about a few things. First of all, cancer happens, especially in Li-Fraumeni syndrome. Screening helps, but we have a lot more work to do, right? Dr. Beglin hasn't taken a vacation in about 2 years, although she's taking one tomorrow, so I'm thrilled, right? She's worked every day, last summer, every day this summer, coming in with her kids after hours, with them playing at her feet while she's pipetting and working so hard. And everyone in our lab works like that, because we're so motivated by patients like Reagan and other families with Li-Fraumeni syndrome, is we know we can't rest until this is done, right? We can't wait for more people to be diagnosed with Li-Fraumeni syndrome. We can't wait for more people to die from cancer who have Li-Fraumeni syndrome. We have to do something about it, and we have to do something about it today. And this is why we're working so hard. And again, we had this big paper that came out last week, and I want to be very careful not to overpromise. There's been too many times where you and others have heard, oh, we found the cure for cancer, and it didn't turn into anything. We're very careful to say, we haven't found the cure for cancer. We haven't even found how to prevent cancer. We're not there yet. It's where we want to go, but we're not there yet. What we have found, though, is how elephants don't get cancer. We think we found the way of maybe how elephants have avoided cancer. Elephants have had 55 million years to learn how to do this. And now what we're trying to do in our lab and working with others is figure out a way to take that information and apply it back to the patients, the children, the families who need it most, so that no one else ever in the future has to be diagnosed with cancer. So with that, I'll stop. I'll thank, obviously, everyone who's worked so hard on this. I mentioned Lisa a couple of times, who really led the effort in our laboratory. Without her hard work and dedication, none of this would be possible. So thank you, Lisa, so much. And the whole team coming in after hours, weekends, really everyone working, Reagan, for you and for your family and for all families with Li-Fraumeni syndrome. The clinical study coordinators, Aaliyah Collin, who was one of the first people to make that discovery about elephants and the P53 gene. So again, not possible without her. And the people at the zoo and Ringling Brothers, Dennis Schmidt and Wendy Kiso, who were so open to working with us and approached us about working together when they heard what we were doing. All of the great sources of funding, and of course, Titan Tough 21. So thank you so much for your time. Thank you for your attention. Thank you, Eric, for sharing the elephant blood with us. This is a painting that Christy the Elephant did and gave to George W. Bush, and I'm told it's hanging in the Presidential Library where people could go and view it and maybe learn a little bit about Li-Fraumeni syndrome. So with that, I will stop, and I'm happy to take any questions. Thank you for your time, and thank you for coming today. Well, this is one of the things we need to explore. So it depends if that benign tumor has any of the mutations in it that's on the panel. So the way the test works is it looks at all of the DNA that you can find that's free floating and sees, are there any mutations in that blood that shouldn't be there. Most benign tumors don't have mutations, but some of them that are on their way to, if they're precancerous, right? And it depends, would you call it benign or not, but if they're precancerous, they may already have one of those mutations, so you may pick it up early. But this is exactly why we need to do the study, because we need to learn, are we going to pick up tumors that really doesn't matter if we found them anyways, because they don't make a difference to the patient, or not? And so this is why we have to study it, just to answer those types of questions. But we're really, really excited, and we want to get the whole Li-Fraumeni community involved in this, because it's only by working together that we're ever going to learn how to really advance the care and the treatment for patients with Li-Fraumeni syndrome. Yeah. Yes, so there are some times when patients with, so I'll repeat the question. The question was, is it true that there are sometimes patients who don't have parents with Li-Fraumeni syndrome, so it doesn't run in their family, they're the only one that gets it? And one of the reasons that I personally believe going forward that we're going to find a lot more patients with Li-Fraumeni syndrome is because, as Amanda knows, our genetic counselor, that we're doing a lot more genetic testing than we ever have before. Now, if a woman who's, say, 30 years old is diagnosed with breast cancer, instead of just testing for BRCA1 and BRCA2, which are the classic breast genes that you may have heard about, also discovered here in Utah, so we're very proud of our history of genetic discovery in Salt Lake City at the University of Utah. But we also now are finding that those women, they're tested not just for those genes, but for many genes, including P53. And we're finding patients who have no family history. They're the only ones, the first one in their family to ever have this P53 mutation. And now they're coming to see us right? Because they want to know what to do, because suddenly they have a diagnosis of Li-Fraumeni syndrome and no one else in their family has ever had cancer. It's just they're the first one at a young age. But someone has to be the first person at some time in all families that develop that mutation. So we do think that, you know, it's going to be a lot closer to 1 in 2,500, maybe even more common than that, of patients, people who have this P53 gene. And in fact, certain pediatric cancers, we always recommend testing because there's such a high rate. So adrenal tumors in children, we always say you should test to make sure there's no inherited or germline genetic P53. Some types of brain tumors, choroid plexus carcinoma, a very high rate. Even if there's no other history, we still recommend that you consider testing. So it's very, very important to always think about Li-Fraumeni syndrome. In fact, 1 in 10 of patients with osteosarcoma, which is a type of bone tumor, may have an underlying P53, certain types of rhabdomyosarcoma. So it's definitely out there, especially in the world of pediatric cancer.
So actually working backwards that way may give it more credence.
Yeah, so trying to say, why is this relevant for all children, not just for patients with Li-Fraumeni syndrome? But the other thing I'll add is, you know, we talk about the elephant P53 and is it useful for patients with Li-Fraumeni syndrome, but remember I started out telling you that over half of all human tumors involve the P53 gene. And many, many tumors, more than half, involve some type of genomic instability or change that P53 somehow didn't pick up. Maybe it was deactivated or mutated, or maybe the cancer found a way of avoiding that. And so what we're trying to understand is, how can this elephant P53, how can this approach of extra P53 actually help not just patients with Li-Fraumeni syndrome, who we care about very deeply, but anyone who's at risk for cancer, which is everyone.
Josh, I had a quick question. So you and I talked a while back about using some nanotechnology and the possibilities of that, of delivering some P53 genes or cancer.
Yeah.
And I know you're working on that. Why don't you explain to the folks what type of hope you have with that?
Yeah, so our hope is, you know, we've got to do a couple of things, right? We've got some benchmarks that we have to achieve before we can actually translate this to help the patients. But this is what we're doing in the lab, right? This is why Lisa's taking her one vacation, because she knows she's going to be busy for the next 4 to 5 years. I'm just joking, Lisa. Okay, so, no, I'm not, but that's okay. So, that's okay, she's all right with it. No. No, so what we need to do is we need to understand which of these extra copies, specifically in the elephant, which of these extra copies are making those elephant cells all die so quickly. And is it going to be a combination of them, or 1 or 2 of them? And once we figure out the mechanism a little bit more, right? Right now we have a potential mechanism, and we feel confident that P53 is involved. But we want to even understand more and do further experiments and drill down deeper with genomic technology, RNA-seq, methylation, what signaling pathways are being activated, so we can really understand clearly how this elephant P53 is contributing. We believe it is, and again, it potentially is, but we want to show it for certain and understand every single individual P53 in the elephant, because each one is slightly different than the other. And then figure out, using, like you said, something, maybe one approach would be something called nanotechnology. Is there a way to actually deliver the P53? It might not be nanotechnology, it may be a different way, but as the science develops, but is there a way to get that right combination of elephant P53 to where it needs to go? And to do that, we're going to need to do lots of different experiments, and we're going to have to understand how it works. We'll have to try it out in different animal models before we ever get to people. And people always ask me, well, how long is that going to take, Dr. Schiffman? Well, you know, at the rate we're going now, it could be maybe another 10 years before we're closer to doing it. But the more funding we can raise, the more support, the more awareness, the more people we could hire, like Dr. Abeglin, who are dedicated and working on this. If we had a whole army of Lisas, right? Lisa is phenomenal, but man, imagine if we had 20 Lisas, right? We would go 20 times as fast to getting to that goal. And like I said, and I truly believe this, we don't have time to wait. One patient with cancer, whether it's a kid or an adult, a father or a mother, grandparent, that's one person too many. So we can't wait, and we need to run like hell. We need to get there as quick as we can, because we cannot afford to have more people developing cancer and dying from cancer if there's a way possibly that we could do something about it. And we don't know yet if there is, but this is why we're so eager and so enthusiastic and so excited to try to figure it out. Yes?
What's the key element to making this run fast?
The key element is, like most things in science, it comes down to funding. It comes down to support, right? You can have 20 people, 50 people, 100 people really excited about it, but if you can't hire them to do the work, well, then it's just a good idea, right? We want to actually create, like the elephant has an army of P53s, we want an army of researchers working around the clock to try to figure out, is there any way that we can take this information, take what evolution has done in elephants, and apply it to people. This is the most important thing to me right now and to everyone else in the lab. Yes?
Okay, so this blood test that you're talking about
Mm-hmm.
will possibly locate tumors
Yep.
quicker than MRIs.
Mm-hmm.
Is that only directly correlated with like the elephant study, or is there a benefit too? So I guess I'm trying to understand is, say that somebody with leuemia got a blood draw and
Yeah.
found like the tumor signals were higher.
Yep.
Okay, is there a way to know where that would be located?
Sure.
If it's located,
Yeah.
like is it too microscopic to do anything about? So is it just like the idea that you know something's there, so you're doing MRIs more
This-
often?
Yeah. So the question is, this blood test, one, is it separate from the elephants, and is there a way to know if you find anything, where's the tumor, or do you just keep doing MRIs till you find it? And the answer is, well, one, yes, this is completely separate from the elephants, right? The elephants is, how do elephants prevent cancer? We think we may have found out a potential way that they do it, and then how do we figure out how potentially, again, everything is with the word potential because we haven't done it yet, because we don't want to overpromise, but we are very excited about it, is how do we use that information from the elephants to help maybe in the prevention, maybe in the treatment, but this is what we need to explore. That's separate than this study of circulating tumor DNA, which we are planning and hopefully going to roll out over the next maybe 1 to 2 months, right? And the exact reason we're doing the study is to answer that question. I'm not standing here before you today saying circulating tumor DNA is the way to go to diagnose an early tumor. I'm saying this is a really interesting, promising approach, and we need to study it to see if it is a way that we can diagnose tumors early in patients with Li-Fraumeni syndrome. And so how would we know whether, if it's a small mutation, if that means there's actually a tumor or not? We know as we age in the healthy human population, as we get to be 60, 70, 80 years old, there's actually a small number of our cells that are circulating with mutations that never go on to become cancer. So we need to do the study in a large number of patients with Li-Fraumeni syndrome, and we need to follow it up so that we can understand whether or not, if we find that signal, if it really means there's a tumor or not, or maybe it's just there's a low level of mutations always in the blood, especially in patients with Li-Fraumeni syndrome, and we don't want to go on a wild goose chase about it. But this is why we need to do the study to see. And maybe there's a certain threshold. Maybe if you find in the blood 5% of your blood cells have this circular, or 5% in the blood, because it's not the cells that have it, you're looking at the free floating DNA, but maybe 5% level of this circulating tumor DNA, maybe that's the threshold when you start going after it with MRI. Maybe it's 10%, maybe it's 25%. We don't know. That's why we need to do this study so that we can answer that question. Right? In medicine, we're very careful and conservative. We don't want to recommend anything to patients until we have at least some evidence that it can work. And this is what we're trying to do now, is to do the study so that we can gather the evidence so that we can benefit all of the patients. We hope that while we're doing the study, maybe we will be able to detect tumors that we wouldn't otherwise do. But the purpose of the study is to answer those questions exactly. Now, I also see in the back that Trent Fowler has walked in the room. I'm going to embarrass him. He's our lab manager. You can wave hello. Trent, he was on that video. Just like Dr. Beglin, he comes in after hours and on the weekends to work because, again, everyone in the lab is so dedicated. So it's a team effort that we're able to do what we do. Any other questions before we turn it back over to James and Reagan?
One last question.
Yes.
Are you currently getting ample enough amounts of elephant blood to accomplish what you need?
Yes, I would say with the partnership with Utah's Hogle Zoo, and especially now Ringling Brothers and their Center for Elephant Conservation, we have good access to elephant blood that we need. But what we really need to be able to do is to study the elephant blood that we already have in more detail so that, again, we can apply it back to the patients and to the families, because it's all for people like Reagan that we're doing this. So thanks so much for your time and your interest, and we're so excited to work with everyone in this room and everyone watching this at home to make a difference.
Good job.
Thanks, sir.
Okay, so I realize we're about an hour and 30 minutes into it. A lot of times I have been to a life insurance sales lecture, and about 25 minutes in, I'm like, oh my gosh, I need to take a nap. So we're going to try to wrap it up. I'm going to have Reagan speak very quickly, and then I'm going to show you how we can reach our goal of $500,000 every 6 months to go into research such as Dr. Schiffman's lab and the great doctors around the world. So I'll turn it over to Reagan, the founder of Titan Tough.
Hello, I'm Reagan Everett, and I am the founder of Titan Tough 21. And the reason I've started Titan Tough 21 is because 4 of my aunts and uncles have died of cancer, and 5 of my cousins. I have also started Titan Tough 21 to provide hope for all leukemia patients around the world. And now I'm asking you to help me. We are only one Titan Tough in Salt Lake City, Utah, but could you imagine if we had hundreds of Titan Toughs across the world? How quickly finding a cure for leukemia syndrome wouldn't just be a fantasy, but a reality. We are all leukemia patients, and in some ways that makes us family. And we're all in this together, so I hope you will go to my website and share your story with me, and also become part of the Titan Tough 21 team.
Reagan said to me before the conference, Dad, do I have to speak? And I said yes. And so you can see that she is a woman of little words, but they're very important. So I'm going to talk about how we, as a Leaf Romini family, can get to our fundraising goals. As I've met with my board, we actually started Titan Tough a little over a year ago, and we built the 501c3 and built the infrastructure and done a lot of great fundraisers. As Jackson mentioned, we raised $10,000 in 4 or 5 days just putting a fundraiser together with the local high school. That is incredible. Could you imagine that? $10,000 in 1 week. And so we wanted to think outside the box. So Reagan just mentioned having a Titan Tough 21 franchise in every single city around the world. Every single city. I'm a businessman. I look at the Coke can theory or the Coke machine theory. If you have 1 Coke machine, you're going to sell so much Coke. If you have 2 or 3 or 4, McDonald's has tens of thousands of franchises, and they make billions of dollars. There's a lot of people out there working hard for Titan Tough, for Leaf Romini research. I'm wanting to bring us all together. So what my goal is, and this is the challenge to the folks who are watching at home, every Leaf Romini family, anybody who has been touched by cancer, I'm saying put together a fundraiser. Let's say we had 50 families in the next 6 months that could do 3 or 4 fundraisers to end up with $10,000. That's $500,000 in 6 months. Let's duplicate that, and let's do it twice a year. If we could do that twice a year, we're looking at $1 million. Mike Singleton mentioned our goal as Titan Tough is to reach $5 million. We will make that goal. But there's only one way we can make that goal, and that is to bring every single Lee Fermini family who is watching this video, or people who have had cancer in their family, to throw down the gauntlet, and let's get this thing going. And let's do these fundraisers. Titan Tough is available to anybody, anytime, anywhere in the United States to help you put these fundraisers together. My mom and my dad always said, if you want something done right, you got to do what? You got to do it yourself, right? So there's a lot of great people working together. And personally, as being the chairman of the board of Titan Tough, it's tough to set up fundraisers. It's tough to do videos. It's tough to set up conferences like this. But think if 50 or 100 or 200 families were putting these things together, how quickly we could come up with a cure and come up with a funding. As we listen to Josh and his enthusiasm, he just said to us that there is an opportunity with the proper funding to reach his goal. I want you to think about that. The Lee Fermini families at home, think about that. All the suffering and heartache and hurt you've gone through. A leading doctor in Lee Fermini research, as well as many other doctors around the world, are now telling us we have an opportunity. We have hope. In the past, Lee Fermini families were Lee Fermini families, suffering alone. Family members are dying, and there wasn't much hope. Now there is hope, and we have great people working for us. That is my goal for everyone on this broadcast, everyone in this room. Do one fundraiser for us, one. Become part of the Titan Tough 21 team. Let's move this thing around the world. That's my challenge. The next thing I'm challenging for all Lee Fermini families, align yourself with people. We have a great collaboration, as Dr. Schiffman said. I've spoken with Primary Children's Hospital. They're allowing donations to flow through to Lee Fermini research. We have people like the Huntsman Cancer Institute Foundation that can take donations. You can donate on the Titan Tough website. So we're aligning ourselves with people that are bigger than us. That's a great business strategy. If you're starting out as a young business, you want to duplicate what you've seen in businesses that are successful. And so that's what we're going to do. We're going to duplicate ourselves. This is a gentleman. This is part of my vision. This is Jonas Salk, if you don't know who that is. Anybody here know who Jonas Salk is? Joshua, who's Jonas Salk? He is the man who discovered the cure for polio. Every summer, decades ago, families would hide in their house. They thought their kids were going to get polio, and limbs were being chopped off, and heart defects. It was crazy. It was a fear inside of the human race altogether. One day in his lab, polio existed. The next day, it was cured. That's how I feel. I have that hope. I believe Dr. Shippen and his lab hold that hope. I believe one day that Lee Fermini syndrome will be here, and the next day it won't. How important is that? Not only to Lee Fermini families, Dr. Schiffman stated half of cancer cells are mutated in some form with the Lee Fermini gene. We're not talking about Lee Fermini families saving themselves, which, man, you don't know how bad I want it, and I know everybody else wants to, but think of being part of an organization or fundraising that cures half of cancer around the world. That is a possibility. Jonas, when he found the cure for polio, the government came and said to him, we're going to let you patent this. You'll have more money than anyone on the planet. And Jonas Salk says, how can you patent the sun? And he released this to the world. How many grateful people were there? How many families that were devastated by polio now found relief? That's what Titan Tough is about. We're going to find relief for Lee Fermini families. We're going to work hard at fundraising. We're going to get together. And let me tell you something. This is one of my favorite sayings. And this is from Herb Brooks in the 1980 Olympic hockey team. I don't know if you know, Reagan's a great hockey fan. My son Drake played hockey, and I'm wearing a state high school hockey championship ring. We're crazy about the sport, but you got to be tough to play hockey. I don't know if many people here have been on the ice or been face-to-face with someone, and you're getting ready to throw down. That is a thrill. And there's a little fear involved, because you know the obvious thing's coming. You're going to start going at it. Well, I've had that feeling, and some of the times I was scared. Let me tell you, I was scared. These guys are big. They're not afraid to get it going. Other times, I just went at it. These are the times we go at it. And he said, great moments are born from great opportunities. We have an opportunity today in the Lee Fermini community to make the difference and to move forward. That's what we're looking for. I'm looking for doers. A lot of people will talk a good game, they'll tell you how great they are, and they'll tell you all the things they want to accomplish. I'm looking for people that are going to dig in and do this. If you're a Leaf Romini family out there, let's get fundraisers together. Let's save ourselves together. And so this is a great opportunity for us. I'll wrap up with 2 slides. Reagan, of course, had her Make-A-Wish. She went to see the Washington Capitals play, of course, hockey and met Alex Ovechkin, one of the greatest hockey players in the world. It was awesome for our family. I'll never forget it. But on her star at Make-A-Wish, it says, "My hope is my foundation does well." What kind of father would I be if I didn't grant my daughter's wish? Wouldn't be too good of a father. So we put Titan Tough together, and we've done what we need to do, and we're going to continue to do it. So as you listen to my words out in the Leaf Romini community, man, take that to heart. Let's make this foundation bigger than it could ever think of being. The last thing I'll show you, then we're done with this broadcast. Whoop, wrong way. Oh, go backward. Am I going backward? There we go. This is my vision of Titan Tough. I shared this with Reagan and some of my friends, and they're like, "Dad, that's a picture." I said, "That's right, that's a picture." This is my vision. As you can see, the dark purple behind these hearts is a cancer cell. Growing and growing. Cancers need to eat. Cancer cells are eating anything around them to grow. The small cells, the small hearts, is cancer medicine delivered to these cells. Josh mentioned they're looking at some nanotechnology that could possibly deliver cancer medicines to individual cells. And the big heart, that's the big one. Josh talked about elephant research and possibly finding a way to get elephant DNA or ways to get that into humans. There's just so much awesome things out there. My vision is enabling people to have a new P53 gene placed into their cancer cell. Could you imagine that? You have cancer. You've got millions of cells in your body, and the research through Leaf Romini syndrome replaces that DNA for you, or replaces that gene. After you replace that gene, you can then get the cancer medicines individually into that cell. There we have something that we can be proud of. Man, could you imagine that? That's my vision. That's my hope. I will be unrelentless in making this happen, not only for my family, not only for my extended family, the Thompsons who have suffered so much, but for everybody around the world. That's my goal. So if you're at home today and you're a Leaf Romini family, you need to do 2 things. One, you need to go to TitanTough21.org. The second, you need to click on the link that says Contact James D. Everett, the chairman of the board. You reach out to me. I'm going to share with you the things we're doing. We're going to do fundraisers together. We're going to do conference calls. We're going to dig ourselves out of this problem as Leaf Romini families. And of course, we'll do all the other big things. We'll contact corporations. We'll go after grants. We'll collaborate with each other on phone calls. But we're going to put this whole thing together and do this big time. So I appreciate everybody watching the broadcast. I appreciate our speakers. And so I think we're at the end. And so we will continue to move forward. Go click on that link, and I want to hear from you. So that's it. I appreciate it. And thanks for watching our broadcast.